For this project, I made a copy of the old Simon memory game, where you have to press buttons in the correct order as the sequence gets longer and longer. The game runs until you press a wrong button or take too long to answer. In the beginning of the video, I'll quickly go over how I built the physical box, but most of the video will be about how I programmed it using agent-based programming in Embrio. I used a folding presentation board for the body. This has nice thick cardboard that's a lot sturdier than what comes in a cardboard box, but it's still easy to cut and glue. I have 4 button assemblies that have a micro switch and an LED inside, as well as 4 resistors for the LEDs. I'm using a TM16374 4-digit display to show the level and the current sequence in the memory. I'm using a buzzer that I got from a sensor kit, an Arduino Nano, a piece of perf board, and several servo connection wires that I'm going to use to wire everything to the perf board. For tools, all I'm using is an X-Acto knife, a ruler, and some glue. First, I lay out the main components so I know how big to cut the front panel. Then I cut that out and the 4 side panels, making them deep enough to fit everything inside. Next, I cut out holes for the buttons, then attach the buttons by screwing in the back. The buttons I used have a little assembly that combines a micro switch and an LED. I used these 3-wire connections made for hobby servo motors that I got in bulk. I cut them in half and use one end to solder to the button stuff and the other to solder to the perf board. Then I use the connection pieces to connect the two. I solder both the LED and the switch's ground to the black wire, the switch to the red wire, and the LED to the white wire. I do this for each button. On the perf board, I solder a resistor to 4 of the digital pins to use to control the LEDs. Then for each of the 4 wires for the buttons, I solder the black wire to the ground pin, the white wire to the end of one of the resistors, and the red wire to another digital pin for the button. Again, I do this for all 4 sets of wires. Now that the buttons are hooked up, I do a test to make sure all the button clicks are detected and the LEDs light up. The 4-digit display needs 4 wires connected to the Arduino, so I used 2 servo connectors and cut out one of the wires from each of them. One set I solder to the ground and the voltage out pins on the Arduino. The other set connects to digital pins 10 and 12. I also use a final set of wires to connect the buzzer to the ground and to the digital pin 11, but I forgot to take a video of that. Finally, with everything soldered to the perf board, I push it in the back of the box and get ready for programming. Alright, now to put together the program, I start with a fresh project in Embrio. I'm going to rename the default agent overview. And I like to do this and use this agent while I'm working to drag agents on and kind of have a high-level view of what's going on. To start a project, I always do the agents that touch input and output pin first. So I'm going to make a new folder and call this I/O for inputs and output. Make a new agent and call it buttons. I'm going to put all 4 buttons on one agent. Sometimes I use a separate agent for each button, but since the buttons are only going to be used as a set here, it makes sense to use one agent. So what I do is I take a digital input pin. My first button is on pin 8. So now at this point I'm going to connect to my Arduino to make sure everything's working right. While I'm doing that, I'm going to get a above or below node and connect the activation to that. The above or below node gives a output trigger when the activation goes above or below a threshold, so I can use that as a button click. So now that I'm connected, if I press my button, I gotta turn on use pull up. There we go. So by default the activation is at 1, and then when I press the button it goes down to 0. So you see when I press the button the go below trigger fires. So I'm going to rename that click. I'm going to have 4 buttons, so instead of having a copy of both these nodes, I'm going to copy these nodes, cut them out of here, add a new node group, call this button, paste them in. So now what I'm going to need to be able to do from outside this node group is change the pin number, so I make that exposed, and the click, so I make that exposed. And then I save it, go back to my buttons agent, and then I can drag this button function here, and then I'm going to make one for each of my buttons. Now that I have 4, I changed my input and output touching nodes. So I'm going to refresh my program. And while I'm here waiting, I'm going to set all the pins. So my second button is pin 9, my third is on pin 6, and my fourth is on pin 7. So I'm also going to rename these button 1, button 2, button 3, button 4, and make all those exposed so I can get at them from other agents. And now I'll test on my hardware. So now they all work. Pressing button 1, button 2, button 3, and button 4. Now I'm going to do the same thing for the LEDs. Create a new agent, call it LEDs. I'm going to use a digital output to control an LED, and then I'm going to use a blend inputs node. I could connect directly to the activation on the digital output node, but I want this agent to expose the current activation of an LED. So now when I connect to this input, it sets the digital output, but it also has an output activation so other agents can see what the value is. Just like the button agent, I'm going to take these, cut them, create a new node group, call it LED, paste it in. Activation and activation are already exposed, and I need to expose the output pin. Save that, go back to LEDs, and I'm going to drag a copy of this. I'm going to call this LED1, call this LED1 as well. So you see when I move the LED input activation, the output shows. And then I'm going to copy this 3 times, update the names. I'm going to make all of these exposed, the activations on both. And then I'm going to update my connection program, and while I'm waiting, I'll set my pin numbers. So now I have a good connection, and I can drag the activations and turn my LEDs on and off. Next, I'm going to set up the number display. Create a new agent, call it number display. And I'm going to use a node from the library. So I open up LCD and display. And what I'm using is a TM16374 4-digit display. So I'm going to set my click pin to 12 and my data pin to 10, which is just where I have my wires plugged in. I'm going to connect again. And now that I'm connected, I can drag my value, and I can see my number go up and down on my display. So I want to use all 4 digits, so I'm going to change the maximum value of this input to 9,999. Now I want to display 2 numbers on this thing. I want to display the current level and the current number in the memory array. So I'm going to make a new node. Drag it on here and open it up. I'm going to call this level and index. And I'm going to add 2 integer inputs. I'll name the first one level, the second one index, and I'm going to have an output integer. So the inputs are going to go from 0 to 99, so I'm going to change the maximum value. And the output is going to have both of those added together basically, so I'm going to change the max to 9,999 again. I add an onChange update condition, and I select both inputs, so when either of these changes, this code will fire. So I'm going to put output integer equals input level times 100. And by doing this, I'm taking whatever the level input is and adding 2 zeros to it. And then I'm going to add the index. And then I just hit save. And now my level changes the first 2 digits of the output number, and the index changes the second 2. So you could do this with these nodes, the add and multiply node, but I find it sometimes easier just to write your own node. So I'm going to connect this to value. So now you see when I change the level input, it changes the level part, and the index changes the index part. So I'm also going to want to be able to change the brightness here. I want the program to be able to turn on and off the display. So to do this, I'm going to start with a activation to integer node. And I'm going to use a blend input to put the to get the default level. So I want it to be, let's say 4. That's a good brightness. The brightness only goes from 0 to 7. So about 4 is a good level. But now I need another activation to turn this one on and off. So first I'll set it to multiply, because I'm going to multiply this value. And I'm going to use a switch. So the switch turns on and off. I connect that to the action. So now when the switch is off, the brightness is 0 and the display is off. And when the switch is on, it multiplies the 1 by the default value, converts it to an integer, which is 4, and it turns on. So if I toggle, I can turn the display on and off. So I'll make the turn on and turn off external so other agents can turn them on and off. And switches start off, so I'm going to add a startup trigger and connect that to the on so this thing starts on. So that's it for now. Later I'm going to, once I get the level and the index values in the program, I'll connect those. I've got one more input-output agent to do, and that's the buzzer. So the buzzer I'm using, it just needs an analog output node to control it. My buzzer's on pin 11. So I'm connected, and all I need to do is change the activation. Whoa, it's very loud and annoying. So I want to be able to turn that on and off. So I'm going to use a switch again. And activation will control it. I don't want it really high pitched like that though, so I'm going to bring the on value down. And I'm going to adjust it till it's something I like. About there is good. And then I'm going to use a timer to turn this switch on and off. And I want the buzz to be quick, so I'm going to move the duration down. That's good. So now I'm going to connect the started output to turn on the switch, and the done output to turn off. So now whenever I turn the timer on, it turns the buzzer on for a quick buzz. So I'm going to rename this buzz, and I'm going to expose it. And there you go, that's it for the buzzer. So now all my input and output agents are done, so I'm going to be able to do the rest of my program without having to refresh the connection. So I'm going to close all these windows just to clean things up. I'm going to make a new folder under the agents folder, and I'm going to call it globals. So I'm going to make a new agent. I'm going to call this one game state. I'm going to use a last triggered node from the flow control menu, and I'm going to add 2 more states. So this node has an input and then a set of an output activation and an output trigger for each input. And whichever trigger you press on the input, the corresponding trigger and activation turn on the output. So this is a good way to control states. I can turn on, state 1, state 2, or state 3. So I'm going to name these states. First I have game over. I'll name the trigger game over start. The second state is example. This is when the buttons flash in the sequence that the user has to press them in. And then the last state is listening, when the user has to press the buttons in the correct order. So I'm going to make all of these inputs and outputs exposed so that other agents in the program can connect to them. Next I'm going to make an agent to keep track of what level we're on. Call it level counter. And for this one I'm going to use an increment node from the math toolbar here. So the increment lets you have a trigger, and every time you click trigger, the output value goes up 1, and you can reset it to start over. So this is a good way to record or to keep track of what level we're on. So I'm going to rename some of these I/O so they make a little more sense. So trigger I'm going to name next level. And then the output value I'm going to call level. And I figure there won't be 100 levels, maybe 50. And I'm going to make next level exposed, reset exposed. I'll expose level, and trigger I'll rename also level incremented. And also make that exposed. So now agents anywhere in the program can connect to this and go to the next level or start over. And then they also know what the current level is and when the level changes. Now I'm going to make an agent to hold the value memory for the game. I'll call it memory control. So at the root of the game, there's a sequence of buttons that a user has to press. Now there's no built-in node that stores a random list of values like that. So I'm going to create a new node. So on the project tab, I'll create a new node definition, drag it onto the screen. I'm going to name it memory. I'll name it number memory. I'm going to have two inputs, a refresh trigger and an integer, which will be the index. And this will be which value in the memory is currently being shown or waited for. I'm going to change the default range from 0 to 100 to 50, or 1 to 50 actually. And then I'm going to have 4 outputs. Activation 4, 3, 2, and 1. So at every index, the way I want this to work is when I click refresh, I get a new array of random numbers. And then when I change the index, I'm going to want one of these activation outputs to light up, and the rest will stay 0. All right, so I'm using I have this checked, which means this code I write is going to be used for both the C# and the Arduino code. So I'm going to start by declaring an internal array. Call it int memory equals new int, and I'm going to give it a length of 50. So when Embrio compiles to Arduino, it takes this C# style of array declaration and converts it to an Arduino array declaration. That way we can use the same code for C# and Arduino without having to implement both. So I'm going to have a couple functions in here. One is refresh memory. Oops. So when that's called, it's going to loop through for int I equals 0, I is less than 50, I plus plus. So for every number in the array, it's going to pick a random number between 0 and 4. This is a built-in function for Arduino, and Embrio implements it too, so you can just use the random. And this is the upper limit, so putting in 4 will give us a number 0, 1, 2, or 3. And then I'm going to call update outputs, and then I will implement update outputs. So when this is called, it's going to take the current index, input index -1. So our index goes from 1 to 50, and the array goes from, arrays are 0 based, so it's 0 to 49. So when I get the index, I'm just going to subtract 1 from whatever the index is. And then for each output, I'll do a little code where it's if the memory of the index equals 0, then output 1 will be 1, otherwise it'll be 0. I'm going to copy that 3 times. 2, 3, 4. If memory index equals, so if the if the value is 1, then the second activation will show up. Or will be 1. So there we go. All right, now I need to update a couple other update blocks. So when the trigger is fired, I'm going to refresh the memory. And then I'm going to make a input changed event. So I press the plus to make an onChange event, and then I'm going to select the index input. So when the index input changes, I'm just going to call update outputs. All right, now I save this. So you see when I refresh, a different activation lights up because the internal memory is changed. And then I can cycle through the index and get my different output states. All right, so that's that. That's the node. I'm going to minimize that. So I need a few more things in this agent. So first I'm going to expose all these activations. So now we need to be able to control the current index. So again, I'm going to use an increment node. I'll change the trigger to go next. I'll change the reset to go beginning. I'm going to expose those. I'm going to change my range to match the number memory. All right, so now this works by, I press go next, and it's going to update the value here. I'll change this to current location. I'll expose that to other nodes. Other agents might want to know the current location. Triggered, I'll replace to gone next. I'll rename to gone next. And then already full will be hit end. This way we'll know when the game's over. And then reset is gone to beginning. I'll expose that. All right, so I'm going to connect the current location to the index. I'm going to expose refresh so other agents can refresh our memory. All right, so now I want the level counter is going to be used to set the range. So when we're at level 1, it's only going to show one piece of the memory and so on. So when we're at level 6, the index will only go up to 6, and then the next level will start. And then finally, I want to know if the memory is at the end or not. So I'm going to make another node. I'll drag this on, open it up, call this one is at end. I'm going to have 2 integer inputs. First one for the current level, second one for the current index. And then I'm just going to have 2 outputs, activation outputs. First one will be called is at end. Actually, is not at end. And the second is at end. So at any time, one of these will be active and the other won't, based on if we're at the end or not. So again, I'll make a onChange event, select both of them. If current is less than level, then output is not at end is true. Output is at end is 0. Else save that. Oop. Oh yeah, got to put input before I use the values. So if input current is less than input level. All right. So just to see how this works before I hook it up, say the current level is 21. Before the current memory location is before 21, so is not at end is showing up. And then once it gets there, is at end shows up. All right, so I'm going to hook up the current location and the level. All right, so now we have this agent that controls the number memory. We can cycle through the locations in the memory, and one of these activations will be exposed, and we know if the memory is at the end or not. So now in our globals, we have the current level and the current index in the memory. So I'm going to add those to the number display, which we set up earlier. So remember we made this node that shows the current level and index. So now I'm just going to drag these on. So I got the level counter. I'm going to connect the level to the level input and the memory control. Clean this up a little. I'll connect the current location to the index here. So now both the level and the current index show up on my digital display. All right, so now I've got all my input and output agents created. I have a good connection, so I don't need to compile again for a while. And I've got all my globals set up. So now I'm going to start implementing some of the behaviors. So I'm going to create a new folder, call it control. And the first agent I'm going to make is going to be called button buzz. So every time the user clicks on a button, I want the buzzer to sound, just to give some feedback. So I'm going to drag the buttons agent and the buzzer agent and simply connect all the button triggers to the buzz. So now you see when I click any button, the buzzer goes off. So that's pretty easy. I'm going to make another one. This one will be called project start. This is going to do anything that's needed for when the project starts. For right now, basically, we just need the game state. We need it to start in game over. So I'm just going to add a startup trigger. So now when the program starts, the game over trigger fires and the game over state is activated. I'm going to add another agent, and this one's going to be called start new game. So this one is going to have a trigger to start a new game, and it's going to set up all the internal things needed for starting a new game. First, I'm going to have the game state. I only want this agent to do anything when we're in the game over state. So I'm going to use a trigger if active node. So what this does is it has an activation input and a threshold. So when the activation is on, if the trigger fires, the output trigger fires. If the activation is below the threshold when the trigger fires, the activation doesn't go or the trigger doesn't go through. Instead, the blocked fires. So I'm going to want this trigger to only fire when game over is on, and I will rename this one start. So for start new game. So now when the user clicks start new game and we're in game over, I need a few things to happen. I want the level counter to be reset. I want the memory control to be refreshed. So this way we get a whole new set of the button sequence. And I'm also going to have the game state. I'm going to drag another copy of the game state just to keep clean connections so we don't have like a connection folding back like that. And this is going to start the example state. So the trigger is going to fire to send the game state to the example state, which is when we're going to show the user the current sequence of buttons that need to be pressed. Now I'm going to make an agent to start the next level. So I'm going to, like the other one, start with a game state and a start with the game state and a trigger if active. So this agent is only going to be active when the listening state is on. Just for test, I'll turn that on. I'm going to rename this to start next level. Expose it. So when the next level starts, we got to get the level counter and increment the next level. So you see the level counter has this level incremented output. So we're going to continue on from there. But the level incrementer could potentially fire at other times, but we only want to pay attention to it when it fires and the listening state is on. So we're going to go to the memory control and go to the beginning, because we're going to start over. At every level, we start at the beginning of the memory. And then I'm going to want to, again, get the game state and go to the example state. But I want to put a little delay in here. I don't want it to happen right away. That'll be kind of jarring for the user. So I'm going to add a timer. I'll call this example start delay. The trigger will turn it on. And then when it's done, I'm going to start the example state. That's too long of a pause though, so I'm going to bring the duration down a bit, maybe to half a second. Boom. Okay, so now when this the start next level trigger fires, the level counter will increment. Oh, we're not in the listening state. So the level counter will increment. The memory control will go to the beginning. There'll be a little delay, and then the game state will go to the example state. Now I'm going to start implementing the actual game states. I'm going to make a new folder under control called game states. And I'll start with the game over state. So I'll make a new folder called game over state. When the game is in the game over state, I want the buttons to blink in sequence to show the user that the game's over. I want the number display to flash, and I want any button to start a new game. So I'm going to start making a new agent called cycle LEDs. So what I'm going to need here is I need access to the game state, so it only happens when game over's on. I need access to the LEDs. And then I'm going to use a timer and a range splitter together. So with my range splitter, I'm going to add 4 states. So you see what happens with the range splitter is when you move the activation, it basically cuts the activation into 4 equal spaces because I have 4 steps here. So what I'm going to do is attach the timer's activation to that. The timer's done. We'll restart the timer. So now we're just cycling through the different activations. And I'm going to connect each of these activations to one of my LEDs. Alright, so the game over, when it starts, it's going to turn on the timer. And then when the example starts or the listening starts, they'll both turn off the timer. So now you notice that even when this timer's off, the range splitter has one activation, so one of my LEDs is on. I don't want that to happen. I only want these LEDs to light up when we're in the game over state. So I'm going to change the blend mode on all these inputs to multiply instead of add. And then I'm going to connect the game over activation to each LED input. So now the range splitter's activation gets multiplied by the game over state's activation, and it only turns the LEDs on when we're in the game over state. Okay, so now I also want to flash the number display. So I'm going to make another agent, call this flash number display. And again, so I'm going to start with the game state. I need to know if we're in the game over state. I'm going to need the number display. So remember, the number display has a turn on and a turn off trigger. And then I'm going to use another timer and a switch, which is just like to blink this thing on and off. So the done on the timer again will restart so that we repeat. And then the done trigger is also going to toggle the switch. When the switch turns on, we're going to turn on the number display. When the switch turns off, we're going to turn it off. So now the number display is blinking on and off. I want it to blink a little faster, so I'll bring this down. Alright, so again, when the game over state starts, that's what's going to turn on this timer. When any other state starts, it's going to turn off the timer. And also, when any other state starts, we're going to want to turn on the number display to make sure it's on. So there we go. When game over starts, my timer blinks on and off. I want to go a little faster. And then when any other state starts, the timer gets turned, or the number display gets turned back on, and the blinking gets turned off. So finally, in my game over state, when the user presses any button, we're going to start a new game. Call the agent anyClick restarts. So we start again with the game state agent, and then we need to know about the buttons. And again, I'll do one of these trigger if active nodes. So we only care about when the game over state is on, and we care about any button click. So you see I'm clicking a button, but the game over state's not on, so nothing happens. So I'll turn on the game over state. So now the trigger fires, and then I'm going to drag a connection to this start new game agent that we made before. So if we're in game over, you see I'll click, and then the game state will switch to example. Okay, now I'm going to work on the example state. So I'll make a new folder, call it example. So the example is when the game is showing the user the sequence of buttons that they need to press. So I'm going to start this by making a helper, which is going to just flash the current button, whichever the memory control is currently on. So I'm going to make another folder. I'm going to call this one example helpers, just to stay organized, because this isn't really one of the main behaviors, but it's, it helps, and it's only used in the example state. So I'm going to call this flash current number. All right, so what I need is the memory control. So whatever activation is currently showing, I'm going to flash that LED. So first, I'll just connect these up. Activation 1, 2, and 3 to LED 1, 2, and 3. So right now, you see that these LEDs are going off because the game over state is on. All right, so I'm gonna use a timer to basically turn on and off this activation, and I'm gonna use a switch as well. So the switch will be turned on and off by the timer, and when the switch is on, its activation will pass through to these LEDs, and we will use the multiply blend mode. So when it's off, so when the switch is on, whichever well, the current level is 1, so the memory control is only showing one piece of the memory. But because of this switch, so if this switch is on, the current memory control will show. So we're going to use this timer. I'm going to rename the turn on trigger to flash current. So this is how other agents will turn this on. So when it turns on, or when this timer starts, turn on the switch, and when it finishes, it'll turn off the switch. So it's really fast or long, so I'm going to bring this down pretty far. I'm going to make it quick, like a quarter of a second. All right, so I also want it to, when the user clicks, or when someone, when the flash current trigger fires, I also want the buzzer to go off. So I'm just going to hook up the started to the buzz. And then I want an output trigger that says when the flash is finished, but I don't want it to finish right when the light turns off. I want there to be a little delay. So I'm going to use another timer. So when this timer is done, this one will turn on. And then when this one finishes, this will be finished. And I'll expose this. And I'm going to make this quick too. All right, so now we have this flash current number. When the trigger fires, it turns on this switch and blends the switch activation with whichever memory activation is on and turns on the LED. All right, so now I'm going to make the first game state behavior. Call this start example. So what this one is going to do is we're going to hook onto the game state, and when the game state example start trigger fires, it's going to take the memory control, send it back to the beginning, and then we're going to start the example by flashing the current number. Oops. By flashing the current number. But we only want to do that when the example state is on. And so we're going to use the gone next trigger on the memory control. But that can fire at any time, so we want to, or potentially fire at any time. So we're going to use the trigger if active again. So when the gone next on the memory control fires, and we're in the example state, we're going to start the flashing the current number. Let me, just for testing, I'm going to move the level up a bit so that we actually have some memory control data that we can go through. All right, so this is the first behavior. It just listens for the example state to start, and then it flashes the current number. So now we're going to have another behavior that continues. It's once the flash finishes, if there are still more memory items to show, it's going to continue. And this is pretty interesting, I think. This is very different than you would. This is very different logic than if you were coding this with traditional programming. This kind of shows off the difference of agent-based programming. So I'm going to call this one continue example. So we care about the game state, the memory control, flash current number. So we want when the flash current number finishes, so we're going to use another trigger if active. So that's the trigger we care about. And we only care about it when the example is on and when the memory control is not at the end. If it is at the end, we're going to end the example state. But this agent is only looking to continue the example state. So you see if we flash, the trigger fires. We're not in the example state. Let me go to the example state. So right now the example state is on. The memory control is not at the end. So after the number flashes, this trigger will fire and pass through. And we're going to call flash current number again. Actually, no. Before we call flash current number, we have to increment the memory control. So again, you can have multiple instances of the agent of an agent node on this agent or on an agent node screen, which makes it easier to read, so you don't have things doubling back. So when this triggers, we're going to go to the next value on the memory control, and you see what just happened. So we need another trigger if active. Oh, actually, that was what we wanted. But we want, in case the memory control gets incremented elsewhere, like during the part of the game when the user's pressing buttons, the gone next trigger will fire. So we only want this to happen when we're in the example state. So there we go. So let me game over, go to the example state. Oh, game over. We started the level counters back down to 0. Oh, no, it's not. So why is that not happening? Where's the memory control? Oh, I hooked up the wrong value here. So when the example starts, we want this to happen not when go on next is fired on the memory control, but when go on to beginning is fired. There we go. All right, so let me show that again. So we go to game over, and then when we go to the example state, the start example agent will fire, kicking off this this sequence, and then this guy will run until is not at end is not true. So now we need one last agent here that is waiting for the end of the example, and then we're going to kick off the listening state. So I'm going to make another agent, call it listen for example end. And this will look a lot like the other agents I made. We need the game state. We need the memory control so that we can get the is at end. Trigger if active, so we only care about this when the example is on and when is at end is true. And then when the flash current number agent finishes while these two things are true, we're going to set the game state to listening. So let me just go through this. So I'm going to kick off the listening or the example state. It's going to show me all my buttons. It's going to light them all up. And then we got to the end, so the game state got sent to listening. Now I'm going to put together the listening state. So the listening state is when the user has to press the button sequence in order. So I'll make another folder under game states, call it listening state. So there's two helpers I want to make for this one. So again, I'll make a helpers folder, listening helpers. So the first one is going to be a timeout timer. So if the user doesn't do anything for a while, I want the game to be over. So we need to have a way of knowing when the user hasn't done anything for a bit. So this agent will have the game state and a button. Actually, I have to make the other agent first. So first I need to make an agent that gives us a right or wrong answer trigger every time the user presses a button. I'll call this button answer. All right, so we need the buttons to know what button was clicked, and we need the memory control to know what button should be clicked. So like for right now, activation 1 is expected. Get my connection up again. So when I press button 1 and activation 1 is expected, I want an output trigger to fire that I got the right answer. So first I'm going to start with two pass-through triggers. I'm going to name the first one right and the last other one wrong. And I'm going to expose these. So these output triggers are going to fire when there's a right or a wrong answer. So this is pretty simple. I just take a trigger if active. So when activation 1 is active, which it is, if button 1 is pressed, then the output trigger fires. And I'm going to connect that to the right pass-through trigger. So now when button 1 is clicked, the right trigger output trigger fires. When something else, nothing happens yet. So let me make a few copies of this. So when activation 2, 3, and 4, and then I hook up button 2, 3, and 4, and then I'll hook up the right triggers to the right trigger output. And then if it gets blocked, it means that was the wrong button press. So these hook up to here and get passed through. So if I press 1, the first button, which is what's expected right now, I get a right output trigger fire. If I press anything else, then the wrong output trigger fires. So now back on my timeout timer, I'm going to drag the button answer. So this being a timer, I'll start with a timer. So this timer is going to start when the listening state starts. And it's going to turn off when other states start. So I want to give the user a bit of time to give an answer, so I'll boost the maximum seconds of this timer up to 3 seconds. And then if the timer finishes, the done trigger fires. I'm going to call this timeout and expose it. So now whenever there's a right answer, I'm going to restart the timer. So it's still waiting for number 1, right? So I'm going to turn on the timer. When I click a right answer, the timer restarts. If I click a wrong answer, nothing happens. Oops. Drop my game. Okay, so now I'm going to implement the main behaviors. I'll start with the start listening agent. So all this one does is going to listen for the game state for the listening state to start. And it's going to send the memory control back to the beginning so that it can cycle through again. So that's an easy one. Now while we're listening, I want, whenever the user presses a button, I want its LED to light up, just to give some feedback. So I'll name this agent lights while listening. We need access to the game state, and we need access to the buttons. And then we need the LEDs. So let's see, how should I do this? So I'm going to use a trigger if active. So this only happens in the listening state. When any trigger is pressed. No, that won't work. Just to make this easy, I'm just going to pass through the activation. So I'm going to open up the button state and open up the button, what do you call this function? So is below fires is on. So I'm going to, this is going to be pressed. I'm going to save that. So now, now I know when a button is pressed. See, so I'm just going to rename these button 1, button 2. And I'm going to expose those. So now we have a trigger for when a button is pressed, and we also just have an activation value for when a button is pressed. So I'm just going to connect these right up to the LEDs here. So right now when I press a button, its LED comes on. But again, I only want that to happen in the listening state. So I'm going to use the multiply input type for all these and connect up the listening state activation to multiply those together. All right, so now we want an agent that listens for a correct answer, and if it finds a correct answer, it's going to increment the memory control. So I'll call this correct answer detector. So it needs the game state. It needs the memory control because it needs to know if we're not at the end. Let me go to the beginning. Go a few levels up. All right, so we want to know if it's not at the end. So we're going to use a trigger if active. So, so if the listening state is on, and we're not at the end, and we get a correct answer, then we're going to take the memory control and go to the next item in the memory. So right now it's looking for the 4th button. So if I do that, you see the memory controls get sent to the next one, and if I press the wrong button, it doesn't. Cool. Go back to the beginning for now. All right, so now I want an agent pretty similar to this one that's looking for the end of the level. So when you press the last correct answer, we're going to start the next level. So we got a level end detector, game state, memory control, when we're in the listening state, and we are at the end. So let me get there. All right, so now we're at the end. And if a right answer is detected, then we're going to use this agent we made a while ago called start next level. And we're going to fire that. Oh, I accidentally exposed an extra input there. All right, so here we go. Level end detector if we're listening, if we're at the end, and if a right answer happens, we go to the next level. So finally, in the listening state, we need a game over detector. So we need the game state. And we need a button answer. So this time we care about if a wrong answer is given. And we also care about the timeout timer. If the timeout timer fires or the wrong trigger fires while in the listening state, we want to go to the game over state. So we'll get a trigger if active again. So we only care about this while the listening state is on. We care about the wrong trigger or the timeout trigger. And if either of those happen, the game state goes to game over. So there's a lot going on in this project. I put this together from a project I already worked on, so I kind of went through it pretty directly. When you're working on a real project, you're going to be jumping around a lot and experimenting and things like that. So let me just get a little bit of data. Embryo's version of debugging is this playback control. You can press the S key and it goes into playback mode. And you can drag this slider and bring back past states, and you can play it like a video player, and your outputs and everything will update too. So you can go through your project and see exactly what was going on in the past 10 seconds by default. So this is a really great way to understand the internals of what your program's doing, because sometimes it's hard to understand while it's running at real time. So this is a really helpful tool. So that was a pretty long video, but if you stuck through it, you should have a pretty good idea of how to approach programming a project like this using agents.